Hello again, guys. I hope you're doing all right. And here we are in the second part of finding roots. Okay. So, guys, welcome back. Remember that on last video we were talking about how to find cubic roots. Okay. So we solved these examples. Remember that to find a cubic root, we needed to do first prime factorization of the numbers that we have, and then we create groups. Okay, because we need a number that multiplied by itself three times and we get the number inside the radical sign, okay, the radicand. So for example, in this case, 64, we did prime factorization. We find all the factors, which were 2, and we created the groups that would be groups of 4. So that would be 4 times 4 times 4, and that was 64, okay? Three groups of number that multiply by itself, and you get 64. And that for that purpose, we needed to do prime factorization, then created the groups, and finally we get the result. Okay. So now, guys, we will see what can we do to find other roots. So here we are with the fourth roots. Why four roots? Because now the index of the root will be 4. Okay, we will have as index the number 4. All right. Okay, guys. So let's start with these examples. What happens if they ask you to find the fourth root of 81? So for that case, we need to do again the prime factorization, the process that we learned before. So let's start doing the prime factorization for 81. All right. So let's see how can we do. Okay, so let's start finding the factors for 81. So we can start, since this is an even number, an odd number, sorry, we're not able to find, it's not possible to divide by 2. So let's try dividing this number by 3. Of course, it's possible. So we divide 81 divided by 3, that will be 27. So again, 27 can be divided by 3, which is 9. 9 can be also divided by 3, which is 3. And finally, 3 divided by 3, which is 1. Okay, so these are the factors that we have for 81. So we have the index of the root is 4. So we need to get groups of 4 numbers that multiply by itself, by themselves, they are 81. So we already have the groups here because 3 times 3 times 3 times 3, this is 4 times 3, okay? So we multiply 3 times 3 times 3 times 3, that will be 81, okay? We already have three numbers that multiply by themselves are 81. So the answer here will be 3, okay? So guys, here we have in the example B, we have the same value, for root for 81, but negative. So the only thing that we need to do is write the negative sign, which is outside the root. So we can write the negative outside, and the answer will be the same, will be 3, okay? Because we already found this value. So for this case, will be minus 3, all right? But what happens here, guys? Here we have a negative number inside the cubic root, the fourth root. Okay, but do you remember what happened when we were asked to find the square root of a negative number? That there's no real solution, guys. So remember the key that we have here, an important tip. When the index of the root is an even number, so we're talking about the index. Remember that the index is this little number of the outside the radical sign. When this index is an even number, okay, and the radicand is negative, what is the radicand? The number inside the root. If the radicand is negative, there's no real solution, okay? So here it happens this case that the solution is not a real number, okay? There is no real solution. For this negative number inside the root, there is no real solution, okay, guys? Always, when this index is an even number. What happens if it's an odd number? For example, as we saw in the last example, for example, here, the cubic root of minus 27. So here it's possible, okay? Because if you multiply minus 3 times minus 3 times minus 3, so if you multiply negative times negative times negative, that will be finally negative. Okay, so that's possible when this number is an even an odd number. Okay, so if this is negative and if it's an even odd number, it's possible. Okay, but here is not possible because this is an even number. All right, there's no real solution here. Okay, so that's the answer for C. So let's check what happens here in exercise D. We are going to find the fourth root for 625. Okay, so let's see. We are going to do the same prime factorization for 625. Okay, so let's see what happens. We're going to find the factors for 625. Okay, guys. So let's start now. If we are going to start finding the factors for 625, we can start dividing, for example, by 5, because it's not possible to divide this number by 2, nor by 3. So we start dividing by 5, and that will be 125. Okay? So if you divide 125 by 5 again, that will be 25. 25. So we can divide 25 again. We can divide by 5, and that will be, the answer will be 5. And again, if you divide 5 by 5, that will be 1. Okay? So we already have all the factors here. And how many times do we have 5 here? We have 1, 2, 3, and 4. So if you multiply 5 4 times, okay, you will get 625. So finally, the fourth root for 625, that will be 5, okay? Because if you multiply 5 times 5 times 5 times 5, that will be 625, all right? Remember, if we had, for example, here a negative sign, the result will also be negative, okay? That will be the case in which that will be negative 2, all right? Okay, guys, so very good. We already know how to find the fourth root. And what if, for example, they ask you to find fifth roots? So guys, that will be exactly the same. But now the difference is that you don't find groups of 4 numbers, as we did in fourth root, but we are going to find groups of 5 numbers that multiply by themselves, and you get, for example, here, 243. Okay, so let's try this. For example, here we're going to find the fifth root. Look at the index here. The fifth root of 243. So let's find it. Okay, let's try to do it. So here we're going to find the fifth root of 243. So guys, again, we come back to prime factorization. So we start doing that with 243. Okay, guys, so we can start, let's try. 243 cannot be divided by 2. So since this is an even number, okay, so we can try by 3, all right? So we can divide by 3, and that will be 243 divided by 3, that's 81. If you divide again by 3, that will be 27. If you divide again by 3, that will be 9. If you divide again, that will be 3, and 3 divided by 3, which is 1. Okay, so let's take a look. If we already have the group of 5 numbers, because look at the index, 5 numbers. So we have 1, 2, 3, 4, 5. So 3 multiplied by 3 5 times, that will be 243. So the answer will be 3. Okay, that will be the answer for this cubic fifth root. All right, that will be 3. You can check that multiplication again. But what happens now if the negative, if the root, if we need to find the fifth root of a negative number? So remember the tip that we talked before. When the index of the root is an even number of the radicand is negative, there's no real solution. But here, this is actually an odd number. So the result will be negative. It's possible. It's actually possible. So if you multiply minus 3, so let's do the test here. So we can try minus 3 times minus 3 times minus 3, 5 times minus 3. If you do this multiplication, if you multiply minus 3 times minus 3 times minus 3, so the number will be 243, okay? Because we already checked that here in the prime factorization. And what about the signs, guys? If you multiply negative times negative, will be positive. If you multiply positive times negative, that will be negative. Negative times negative, that will be positive, and positive times negative, that will be negative. So it's possible to find the negative result, negative 243. So that's possible too, okay? So the right answer will be minus 3. So the same factors, but with the different sign. Remember that it doesn't happen with the square root or fourth root or sixth root when the index of the root is a even number. Okay, it doesn't happen there. It's not possible to find a real solution. Okay, guys. So that's it for today with this video. So after this, guys, remember that we will do a practice in MyMATLAB related to how to find the different roots of numbers. All right. So guys, have a great day. Bye bye. I hope you really understood this part. Okay. See you. Bye bye. Have a great day.